All right, well, you're reading this line, you're thinking, hey, this is now we're talking. At last, he's going to let us use a stinking calculator. Now, you need to remember, there's an old curse, may you get what you ask for. In the past, I've actually had this happen. We're working on this stuff or something like it, and students say, please, please, please let us use a calculator. Please, 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 we want to use a calculator. And then we start to do this stuff where not only will I allow you to use a calculator, I expect you to use a calculator. And then that starts to happen and students start to say, please don't make us, no, we don't want to use a calculator. Please, please don't. So be careful. It does help make things better, a few things better, but you need to make sure to use it correctly. The problem is it's easy to use your calculator incorrectly if you don't have an understanding of the notions that we're developing. So it's important that you have understanding of, for example, reference angles. You need to understand quadrant check. If you don't understand those, the calculator is not going to understand it for you. It will give you an answer. It just might not be the one you want. And you need to be able to take the information that the machine gives you and then interpret it in the proper fashion. If you are not able to interpret it properly, then it doesn't matter what the machine gives you. You're not going to get the result you're looking for. So, again, my calculator is this TI, whatever this is, 83 plus. You do not need to have the graphing calculator. If you do, that's wonderful. If you don't, that's wonderful. Any standard scientific calculator, you can probably go to, I don't know, Walmart or somewhere, and probably pick up a decent scientific calculator for probably under $20. Just an ordinary scientific calculator. If it has sin, cos, tan, which is sine, cosine, tangent, somewhere in the calculator, you're going to be good to go. Notice it doesn't have cot, sec. It doesn't have cotangent, it doesn't have secant, it doesn't have cosecant. But you don't need it on the calculator because you are going to know how to make that happen if you need it. Okay, so the good thing is, for most of the work we're going to do, at least in the short term, you're not going to need to know that. We will have a few exercises. I will be asking you to find cotangent of some angles, but that's because I want to make sure you understand how the process works. Okay, so the first thing, our rule of thumb. So make sure your calculator is in degree mode. Make sure your calculator is in degree mode. The simplest way to do that, the simplest way to check if your calculator is in degree mode, I do it all the time. I don't want to fiddle-faddle with changing. I just want a quick way to check it. I do sine of 30 degrees. If you do sine of 30 degrees and you get 0.5, you're in degree mode. If you do sine of 30 degrees and get some other bizarre number, you are not in degree mode, so you need to fix it, put it back into degree mode. How you do that is based upon what kind of calculator you have. I don't know what kind of calculator you have. It's going to be a challenge for me to tell you. So you need to figure that out by going online and Googling your calculator type and how do I change to degree mode, and it's going to be right there. It'll tell you click, 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 and you'll have it. All right. The other thing, some calculators, if I want to do sine of 30 degrees, some calculators, you must hit the function first. I hit sine first, and then I type in 30 and hit equals. Other calculators, and in particular, if you are using your phone, if you take your phone and turn it sideways, you'll have the trigonometric functions. That's not the best thing in the world, but if that's what you want to use, that's fine. Your phone, for example, you need to first hit the angle and then hit the function. And some scientific calculators are the same way. You have to first put in the number and then hit the function. Others, you hit the function first and then the number. So whichever way works for your machine, I leave that to you to figure that out. All right? But the simplest way to make sure you're in degree mode is to hit sine of 30 degrees. If you get 0.5, you're good to go. Now, our next rule is this. So just do this. Everyone, I'm going to pick a number out of the blue sky, 28 degrees. Give me sine of 28 degrees. Sine of 28 degrees. And so my machine is on, and I do sine of 28, and I hit enter, and my number says, I've got enough chalk here to start a war over, I have 0.469415628, and that goes, if you had more decimal screen, it would go on and on and on and on. Unless it works out to be a nice, even like fraction, like 1/2, unless it's something special like that, these values are transcendental. They go on forever. The decimal never terminates. It never stops. It never repeats. And so what we will need to do is a decimal approximation. This is the standard that I will use. When I hit sine of, 28 degrees, what I got was 0.469471 5628, and if I had a bigger screen or more stuff, it would go on some more. This is the standard that we will use in this course. When I put answers on the exam, this is the standard I will use. And it's important because if it's multiple choice, you might do something slightly differently than I do, and you might miss it by 1 decimal place. So this is the rule that I will use when I make up all the answers on all the exams. Round this number. Whenever you get a number like this, round it to 4 decimal places. 4 decimal places. 4 places after the decimal. If it comes out even, that's fine. If it's 0.5, you're done. 0.5 and you're out. If it's 1, you're done. 1, you're finished. But if it's a long decimal string like this, so for our purposes, we will round it to 4 decimal places, and we will use the simplest rounding formula that you'll ever have. 0 to 4, you round down. 5 to 9, you round up. That's all we're going to do. It's straightforward. If you want to use a different rule on some other place, that's fine. But for us, this semester, this course, so I'm going to round this number based upon the 7. Since this is greater than or equal to 5, I'm going to round this up. So for our purposes, we will write the following. We will write that sine of 28 degrees is equal to 0.4695. If you put 0.4694, that will be marked wrong. That means you either had the wrong number, or you did not round correctly, or you didn't follow directions, or something went off the beam. If this is what we get for our result, and I ask you to put your answer in that spot. Remember, some of the questions will be short answer. So I might ask you to find something, and your answer might be this. If you put 0.4694, that's going to be marked wrong. If this is the value you get, 0.4695, round it to 4 decimal places. All right? 4 decimal places. Suppose we have, let's do tangent of, pick a number out of the blue sky, 81 degrees. Tangent of 81 degrees is 6.31375. Tangent of 81 degrees I have is 6.3137515 something. Round it to 4 decimal places, 4 values after the decimal. 4 places after the decimal. Since this is 5, you round this up. 0 to 4, you round down. 5 to 9, you round up. So we will use tangent of 81 degrees is equal to 6.3138. That's going to be our value that we will use. This is how we're going to write that. Technically, this should be an approximation, but in this context, we will assume this symbol means either equals or approximate as appropriate. So that's our standard, that's our benchmark, that's our definition. Tangent of 81 is 6.3138. I don't know, pick another one. Cosine of 42 degrees. Cosine of 42 degrees. I have 0.74314 4 something, something, something. Doesn't matter because I'm not going to use it anyway. Round to 4 decimal places after four digits after the decimal. Four digits after the decimal. Since this is 0 to 4, that means you just truncate. Do not round this up. You leave it alone. So we will use, this is equal to 0.7431. All right? That's how we're going to use the function values. That's how we're going to round. That's how we're going to express our results. 4 decimal places. Unless you are explicitly instructed otherwise. Unless you're explicitly instructed otherwise, you will use 4 decimal places in the results anytime you compute a function value. Anytime you compute a function value. Anytime you compute a function value, and if you're allowed to use the machine, use four digits after the decimal unless you are explicitly instructed otherwise.